Hi, I'm an old guy and I do maths. Today we're going to try and sketch the graph of y equals negative tan 3x. The domain of x is from 0 to pi. Otherwise this just becomes too messy. Okay, so let's get started. Okay, there are two features here, the negative and the 3 in here. Let's deal with the 3 first. The period of this graph is pi on n. Now this differs from sine and cosine graphs, which have a period of 2 pi on n. So in this case the period is going to be pi on 3, pi on this number. So let's deal with the other aspect of this. Now here is the graph, and what I'm going to do is I'm just going to talk my way through this very slowly. The first thing I want to deal with is the asymptotes. Now normally the asymptote for a tangent graph y equals tan x, the first asymptote would be at pi on 2. It would be here. And the graph would run from somewhere close to the asymptote down this way to 0. Put 0 in there so that you can see what I'm talking about. Now, because the period of this graph is no longer pi, it's pi on 3, the period has been cut in 3. It's been diminished from 1 pi to 1/3 of pi, which means that our original asymptote that was here has now moved to here. It has gone from pi on 2 to pi on 6. Now a very easy way of calculating that is to take this number, the 3x, so this number here, hope you can see that, yep, 3x, and multiply the denominator here, and that gives us pi on 6. That's our first asymptote. So that's how we get that. Now, a normal tangent graph, as I said, would have its first asymptote at pi on 2, and it would run like that, down towards 0. So if this were positive, with our constricted period and our asymptote here, this would run down along this dotted line here, but it does not. And it does not because the graph is negative tan 3x. So it is reflected in the x-axis. This moves to here. They meet here at 0, and so this is the first part of the graph. Runs from 0 to pi on 6-ish. It approaches pi on 6. Pi on 6 is an asymptote. Now, where's the next asymptote? Well, the period of this is pi on 3, so we take pi on 6 and we add pi on 3 to it. That gives us pi on 2. 1/6 plus 2/6 is 1/2. It's time to learn your fractions if you don't know them already. Again, the normal trajectory of a tangent curve would be like that, but this is reflected, and so it does that. The point it passes through here is halfway between pi on 6 and pi on 2. So that is pi on 6 plus 1 pi on 6 plus 2 pi on 6 to get here, to give us pi on 2, and therefore this is pi on 3. 1/6 plus 1/6. We have an asymptote here, as I said. The period, just at the risk of repeating myself, is pi on 3, so we add pi on 3 to pi on 2, and we get this point here, which is actually, I haven't written this in, it's 5 pi on 6, which can be found, as I said, by adding pi on 2 to pi on 3, or subtracting pi on 6 from pi. And again, the trajectory looks like this. The midpoint here is 2 pi on 3. pi on 3 away from there. Everything in this is symmetrical. And the next thing to observe is that we just have this little piece left here. This distance here is pi on 6. From here to here is pi on 6. And so we get in half of the normal trajectory of a negative tangent graph. And so this runs from here all the way down to pi. And that is how we construct the graph of y equals negative tan 3x between 0 and pi. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.